Hi, for section 2.1, I'm going to do 3 separate videos. In the first video, I'm just going to talk about functions. What is a function? Well, you probably are already very familiar with the idea of a function, but I want to give you some ideas of mine that can maybe help if you're not totally clear. A function is a relation. Usually we see it written as an equation, but it doesn't have to be. That produces exactly one output which usually we call y in its range from exactly one input which we would call an x in its domain. I'm going to talk really specifically about this exactly one output from exactly one input idea. Before we do that, let's recall that the domain of a function is the set of all inputs. Usually we use x for that, and that the range is the set of all outputs, or y. Okay, we're going to look at the graph of a function. Recall that if you have a function, you can use the notation f of x, remembering that this does not mean f times x in the usual way that parentheses do. This is a second use of parentheses. So f of x equals 1 over x is also known as the reciprocal function. The reciprocal function. Yeah. Why is this a function? Well, for any x that I can pick in its domain, I get only one y. Alright, let's take a look at a table of values so that we can graph this. If I plugged a 1 in for x, I'm going to get 1 for f of x or y. If I plug in a negative 1 for x, I'm going to get a negative 1. If I plug in 2, 1/2. If I plug in 3, 1/3. Notice the function always creates the reciprocal of the input. If I put in the function negative 1/2, the reciprocal of that is negative 2. Alright, so notice each x we put in, we only get one y. We don't get a different y. We don't get 2 different y's or more than 2 different y's for any x. So let's take a look at the graph of 1 over x. Here's a point at 1, 1. Here's a point at 2, 1/2. Here's a point at negative 1, negative 1. Here's a point at 3, 1/3. And a point, there's also a point at negative 1/2, negative 2. I'm going to have to move this label in order to make space for that point. So this is what, negative 1, negative 1. And here we're going to have negative 1/2, negative 2. Again, you can see that if I put in 2, I would be at, negative 2, I'd be at negative 1/2. If I put in negative 3, I'm going to be at negative 1/3. If I put something here at 1/2, I'll be at 2. So we see this function looks strange. It's in 2 pieces, and it looks like this. Now let's talk about its domain. The domain of the reciprocal function ends up being negative infinity to 0, union together with 0 to infinity. Another way to say this is all x such that x does not equal 0. Why is this true? Well, notice if I tried to put 0 in, I would get 1 over 0. 1 over 0, if you might recall, is undefined. Then if we start to look at the range of this function, we see again that it is negative infinity to 0, union 0 to infinity. Or all y such that y does not equal 0. Why is that? Well, you can never get 1 over 0 out of this function, right? If you tried to put, you can't get 0, is what I'm trying to say. Back up. It's not that you can't get 1 over 0, although you can't. You can't get 0. 0 is not the reciprocal of any number. Okay? So the function gets closer and closer and closer to the x-axis and the y-axis, where y equals 0 and x equals 0, respectively. But we never reach either one of those for x or for y. Notice we only get one output for each input right here. We never get two outputs for any input. What happens for all functions is that 1x gives only 1y. We can get the same y for a given x, but we can't get more than one y for an x. Yeah? Listen to this. I like to think about functions in this way. Let's say you go to Walgreens with a friend, and you and your friend want to both get a Coke. And you decide that you're going to get exactly the same kind. The same size, the same flavor, everything. You walk up to the cash register, and the man behind the cash register says to your friend, "That'll be $1.89. Your friend hands over the money and says, "Thank you." Then you walk up to the cashier, and he says, "Oh, for you that's going to be $1 million." And you say, "What? That's crazy," right? So the fact that you can get a Coke, he got a Coke can for $1.89. So you get a Coke can for $1.89, you get a Coke can for $1 million, right? If this could work in the world, which it never would, right? If this happened in the world, I mean, it would never fly, right? No one could ever buy anything. You'd have to walk in someplace and you wouldn't even know. You wouldn't know if you could afford it. So things in our world have to be functions because we need to have predictability. Not every equation is a function, although most of the time we like functions because they can help us predict our world. But it is important to note that not everyone is a function. Okay, so I'm going to show you an example of something that's not a function. Yeah, its graph looks like this. Here's 1 on the x-axis, and its equation, notice it's not a function, so I can't use f of x, is x equals y squared plus 1. Let's take this equation and solve for y. I'm going to subtract 1 on both sides, and then I'm going to take the square root. It's important to note that when I take the square root of the left-hand side, I have to realize that it's going to be positive or negative square root of x minus 1 equals y. Why? Well, the reason for that is that when you solve for y, you're looking for any value that you can plug into y to make this a true statement. So notice if I plugged in a minus or a plus square root of x minus 1 into the original for y, because it's equal to y, because it's equal right here, it would get squared, and it would be the same value. It would become positive. Okay, so we have to say either the positive or the negative square root of x minus 1 is equal to y. But notice when we look at this, description of this equation or relation, automatically we see that if we can put in an x here, we're going to get, if we put in one x here, we're going to get two y's. We're going to get a positive, whatever happens here, and a negative, whatever happens here. We can take a look at a little table of values just to make sure that we believe this. So let's say that we put in a 1. Yeah? Well, 1 minus 1 is 0. Square root of that is 0. Oh, we only get 1y. That's because we have this point here on the x-axis of our graph. Point here on the x-axis. What happens if I put in a 2? Well, if I put in a 2, inside the radical we get 2 minus 1, which is equal to 1. Square root of 1 is 1, so we get plus or minus 1. So notice I put in an x and I get two different y values. That's why it's not a function. I'm only allowed to get one number, right? One Coke equals one price.